Okay, so part B, it says find the equations of the tangents to this curve at the points where the curve intersects the line x equals 1. So I've just written here, find the equation of the tangents at x equals 1. Now this isn't a curve that we're probably familiar with seeing here. There's going to be multiple times where this intersects with the x equals 1 line. So there's going to be two different tangents. Now the process of this is we want to sub in x equals 1 back into the original function to find what y would equal. So if we sub in 1, sub in x equals 1, sub in x equals 1 into the original equation, we're going to get 3 times 1 minus 2y squared times e to the 1 minus 1 equals 2. And we want to solve for y here. We're going to get 3. Now I'm going to put the 2 on this side. Minus 2 will equal, and I'm going to put all of this on the other side. This will be 2y squared, and e to the 0, which is 1 minus 1, is just 1. So times 1. So therefore, this will be 1 divided by 2 is a half, and the square root of that, or y, will therefore equal plus or minus 1 on root 2. So I have two values for y. For my value of x, y will equal plus or minus 1 on root 2. To find the equation of the tangents, I need to first find our gradient of the tangents, and the way we find that is just sub in x into our derivative. So dy, and our y values. So dy dx, and just for our knowledge here, this is when x equals 1, y equals plus or minus 1 on root 2 will equal. So I'm using our answer from part A, 3 times e to the 1 minus 1 minus 2y squared. So if I have plus or minus 1 on root 2 all squared, all over 4 times plus or minus 1 on root 2. So I'm going to get 3. Now e to the 0 is just 1, so 3 minus plus or minus 1 on root 2 squared, or square top square bottom. It's just going to be 1 on 2, a half, and 2 times a half is just 1, so 1 over, and 4 times 1 on root 2, we can just simplify that as plus or minus 4 on root 2. Okay, and this will be 2. The root 2 comes up, so this will actually be 2 root 2 on 4, which is plus or minus root 2 on 2. Okay, so what we have found, I'm going to color code this. When y is positive 1 on root 2, we're going to get positive a gradient of root 2 on 2, and when y is negative, we're going to get a negative m here. This is m, of course. Okay, so let's now find the equation of our tangents. So the equation will be y minus y1. Now let's use the positive one first. So y minus 1 on root 2 will equal m, which is positive root 2 on 2, x minus x1, and x1 is just going to be 1 for both of them. So that's one of our tangents. So we're going to have y minus 1 on root 2. Now 1 on root 2 is actually the same as root 2 on 2 if you times top and bottom. So I'm actually going to do that now. Y minus root 2 on 2 will equal root 2 on 2x minus root 2 on 2. And then if I add the root 2 on 2 over, this will actually disappear. So y will equal root 2 on 2x. Now the other one will be y minus minus, so it'll be y plus 1 on root 2 equals negative root 2 on 2, our gradient, x minus 1. So y plus, now I'm going to write this as root 2 on 2 equals negative root 2 on 2x plus root 2 on 2. And again, now this is positive. If I move it over to the negative, they'll cancel out. So I'm going to get y equals just negative root 2 on 2x. Okay, bit of a long question here, but I have my two tangents. It's going to be root 2 on 2x and negative root 2 on 2x. We could write this as plus or minus root 2 on 2x, but I've got two different tangents here. Okay, that's the answer.